Welcome everyone. Thank you for joining us for today's webinar. My name is Matt Bowen. I'm a research scholar at the Center on Global Energy Policy at Columbia University. Today we're going to be discussing nuclear energy cooperation between the United States and its allies. Let me first quickly say that this event is being webcast live and the full video will be available online in the coming days. For those of you joining via Zoom, you can submit a question for the panelists at any time by clicking on the Q&A button at the bottom of your screen. For those of you watching the live stream anywhere else, you can submit questions via Twitter using the hashtag CJEPLive and our Twitter handle at ColumbiaUEnergy. We have a great group of folks for discussions today. Chris Colbert, who is the Chief Strategy Officer from NuScale Power, joins us. NuScale is a leading US small modular reactor company. Chris brings a long industry background in energy projects, both nuclear and not, which will be great perspective to have. Joyce Connery is a board member with the Defense Nuclear Facilities Safety Board. Joyce has worked in a variety of different positions in the US government, including US Department of Energy and the National Nuclear Security Administration, as well as the Deputy Secretary of Energy's office. She's also done 2 stints in the White House at the National Security Council. The first focused on WMD threat reduction, including the Nuclear Security Summit, and the second as a Director of Nuclear Energy Policy. Amy Roma is a partner at Hogan Lovells, where she specializes in nuclear and radioactive materials law. She worked at the US Nuclear Regulatory Commission's Atomic Safety and Licensing Board panel, and is actually testifying tomorrow before the US Senate Environment and Public Works Committee on some of the topics that we'll talk about today. I'm going to lead off the discussion with a presentation related to a recent report on strengthening nuclear energy cooperation between the United States and its allies. And then we'll have a discussion afterwards that will be broader than just what's in the report. Let me open up these slides. Okay, a quick overview. I'm going to talk about some of the rationales for strengthening cooperation between the United States and its allies on nuclear energy, climate change, some of the challenges posed by Russia and China. I'll also talk about some of the headwinds that nuclear power is facing in the United States and several allied countries, as well as a case study on cost associated with advanced reactor development and demonstration. There are a variety of different ways the United States government could look to strengthen cooperation. I wanted to talk about 2 of them, which are discussed in the report, but we'll talk about more later on in the discussion period. There are other reports out there that also discuss allied cooperation. Bob Eichord at Atlantic Council, Jennifer Gordon also at Atlantic Council has written on co-financing nuclear projects with US allies. Andy Patterson has written something for Gabi on an allied response to China and Russia in nuclear energy. But underlying all of these pushes, at least for me, on nuclear energy is concern about climate change. For as much as there's been focus on climate change in the last number of years, global emissions have risen, where if we're really trying to achieve decarbonization by mid-century, we need to be seeing drops in global emissions. And instead we are headed in the opposite direction. This talk isn't on climate change, so I will refer to a recent publication that came out on nuclear and climate. But suffice to say, we're a long ways away from a zero carbon energy supply. On a completely separate direction, it used to be the case that the United States was the leading supplier of reactors to other countries. That was now what feels like a long time ago. For anyone paying attention the last couple decades, Russia has assumed that mantle. They have been the leading supplier. Actually, at the moment, there isn't a US reactor under construction outside the United States. If Russia is currently the leading supplier, China is certainly waiting in the wings. They have the largest domestic reactor build in the world. And again, I don't want to spend too much time talking about this, although we will discuss some of the geopolitical national security considerations involved here. I have a piece coming out in a number of weeks, but again, Bob Eichhorn at Atlantic Council has also written on this topic. I don't think it'll surprise anyone on this call. Certainly nuclear power has been challenged in the United States and several other countries. The first AP1000 construction projects have gone very badly. We have a lot of cheap natural gas here in the United States, which isn't necessarily the case in other countries. In Japan, they're considering what reactors will possibly turn on in the future and what reactors may never turn on. And certainly that's a challenging public environment right now. Germany's decided to exit nuclear power, I believe, by 2022. There's been some discussions in other countries about similar actions. South Korea the Moon administration has decided to cancel planned new reactor builds and shut down existing reactors at the end of their operating licenses. And of course, the French EPR builds have also gone fairly badly. I'm certainly of the opinion that advanced reactors are a way forward, but there are substantial costs involved with their development and demonstration. These are numbers from NuScale, and in particular, I'm looking at the first-of-a-kind plant costs, the total overnight cost for a unit. NuScale's estimate is $3 billion about. Now that doesn't include some other costs, contingencies, owner's costs, which would push the total number up a bit, but it's a substantial amount of money. I will leave it to Chris to talk more about the safety case, but since he doesn't have slides, I wanted to at least put up a graphic of NuScale's reactor building. You can see the 6 reactor modules and the large pool of water. At least part of the safety case for NuScale is when reactors shut down, the residual heat from the spent nuclear fuel has to be managed. And in NuScale's case, they've set this up so that without offsite water, offsite power, or operator interaction, that heat can be passively transmitted into the pool of water that the reactor modules sit in. What I think is really interesting, and what I had asked NuScale to supply, I'd heard them talk about this $1.4 billion in development costs, their estimate for what it's going to take. And I asked them if they would break that out for educational purposes, for discussion in the wider community. I think it's a really interesting data point. I actually am not familiar with many other papers that try to get at, if you have a new company that's trying to commercialize an advanced reactor design, what are the development costs associated with that? And also pertinent to our discussion, and also what I will let Chris talk about in more detail, are the partnerships with entities in various allied nations that have contributed investment towards NuScale and also helped to keep their development costs lower than they otherwise would have been. Now, I worked in Office of Nuclear Energy for a number of years and went to some of their international events. One question I always had in my mind was what are we trying to do? What's the objective? What are we getting done at these meetings? And if we pursue in the United States an advanced reactor demonstration program, like what is envisioned in the Nuclear Energy Leadership Act, trying to demonstrate several advanced reactor concepts, and NELA would require the Secretary of Energy to do this. My question was what role could our international programs serve in that effort? And I was looking at the two kind of established forums, the Generation 4 Forum and the International Framework on Nuclear Energy Cooperation. These are forums that were created a while ago, so I don't mean this to be a criticism of them per se. They weren't created for this, for the purpose of supporting allied cooperation on advanced reactor demonstration. But in terms of thinking about whether or not they could be adapted or used for that purpose, at least a couple of things seem somewhat awkward. Generation 4 Forum is a long time ago decided to focus on 6 reactor concepts. I've listed the acronyms here, but gas-cooled fast reactors, lead-cooled fast reactors, molten salt reactors, sodium fast reactors, supercritical water reactors, and very high temperature reactors. Now what's missing are some of the small light water reactors, GE's 300 megawatt boiling water reactors, NuScale's small pressurized water reactor, Holtec. None of those would fit into those categories. And at least to my mind, to my knowledge, no US companies are pursuing the supercritical water reactor. So in terms of the technological limitations to Gen 4, that seems a little bit challenging. And at least in my mind, a US advanced reactor demonstration program should be pursuing concepts that utilities are interested in deploying and be a bit more technology agnostic. A second dynamic is that Generation 4 Forum, as well as IFNEC, include China and Russia. And for some reasons I'll discuss on the next slide, it's very hard for me to see how we're really going to cooperate with China and Russia on advanced reactor demonstration in any meaningful way. Again, I'm not trying to be so critical of Gen 4 Forum. It was set up almost 20 years ago. But there have been a lot of developments in the last 5 years, including the Paris Agreement, which included this two-pronged approach of mission innovation and breakthrough energy coalition, a group of nations that committed to greater public investment in clean energy technologies, and a group of private entities, private individuals who are funding clean energy development, including nuclear power. Bill Gates has his nuclear company, TerraPower. As I mentioned, the last few years have seen some pretty substantial developments. In 2018, the US government announced a pretty substantial change in export control policy, effectively shutting off cooperation with China. The specific policy is essentially a presumption of denial for all advanced reactor exports to China. And even before that, there had been a case where the US government had indicted a Chinese entity, CGN, China General Nuclear, and that indictment remains in effect. It's in the headlines almost weekly, but the US relationship with Russia and China has certainly deteriorated as well, whether it's on trade or election interference. So that's part of my reason why I have a hard time seeing how we're going to cooperate with those two nations in a meaningful way. And it's part of why I think we may need to consider some sort of other multilateral forum or a series of bilateral initiatives with probably a small group of countries. I suggested in the report potentially looking at a cross of US allies and mission innovation countries, potentially with the nations that have existing nuclear programs. Now, in the United States, we've had a couple of other interesting developments in the last few years. States have passed clean energy standards. Utilities have declared they're going to be zero carbon by roughly mid-century. There was the nuclear production tax credit that was passed in 2018, which would allow advanced reactors to qualify in the 2020s and 2030s. And there's certainly been a lot of discussion in Congress about what future climate policies could look like. And then finally, the Nuclear Energy Leadership Act, as I mentioned, would require the Secretary of Energy to demonstrate several advanced reactor concepts. And it's got a nice bipartisan co-sponsorship list to it. I've listed the Senate, but it's also true in the House. And actually, NELA has made its way into the National Defense Authorization Act that the Senate passed. It's not in the House version. And I'm not sure what will happen in conferencing, but I think all of this is context for potentially exploring new international dimensions to DOE's nuclear energy programs, or more generally the federal international programs over the next decade plus to try and support that advanced reactor demonstration. The second topic I wanted to bring up are some outdated laws that are discussed in the report that have been problematic for investment by allied nations, entities from allied nations in the past, and could be again in the future. So this is digging down a little bit into the weeds here, but there are sections of the Atomic Energy Act that were passed in 1954, at least substantially, and they, they were not particularly well explained when they were passed, and they have been subject to varying legal interpretations ever since. So the foreign ownership, control, domination provisions have been called the primary legal barrier to outside investment. And we continue to see discussions over what exactly the provisions should mean for investment by even some of our closest allies, Japan, France, Britain. But historically, the US nuclear regulatory has interpreted this to mean that some indirect ownership is allowed for US nuclear power projects, along with potentially measures to negate aspects of control or domination, what are referred to as negation action plans. And these mitigation measures can require, for example, that safety and security decisions be made solely by US citizens, or require certain key personnel to be US citizens. Just as a reminder, and perhaps in fairness to Congress, when they passed the Atomic Energy Act, the world was quite different than it is today. For one, we really didn't start to build power reactors, at least in earnest, until decades later. And back then, we had a fairly integrated US supply chain, whereas today we don't even make some of the large safety components for the reactors that we're building, for example, in Georgia. They're made elsewhere. And this is part of what the US Nuclear Regulatory Commission argued 20 years ago, is the international context today for cooperation looks a lot different than it did more than 60 years ago. There's an NRC document that looks at 17 cases going back many years where these provisions have been problematic. I'm not going to go through all of them. I was going to quickly discuss two. And the first one is there was a project to build advanced boiling water reactors in Texas, where a Japanese entity, Toshiba, had only a 10% stake in the project. But NRC staff and interveners argued that the project, at the particular stage that it was at, and given where investment levels were, violated the FOCD provisions. And this came before the Atomic Safety and Licensing Board, and even though staff admitted essentially they were unaware of anything about the project that was inimical to US interests, and they didn't have any particular non-proliferation concerns, no concerns about the country involved, they were still arguing that this violated this provision from 1954. However, the board ultimately ruled in favor of the project owners. Still, this put the project in some degree of limbo for several years, and that kind of uncertainty certainly not helpful towards encouraging investment. The second case involves an expansion at the Calvert Cliffs plant in Maryland, where a French entity had at least initially partial indirect ownership and later 100% indirect ownership of the project. And again, interveners challenged the project on FOCD grounds, and ultimately the Atomic Safety and Licensing Board agreed that the arrangement did violate FOCD. Now, in both these cases, there were negation action plans that put safety and security decisions exclusively in US hands. But as you can see, nearly 60 years later, this provision has continued to throw uncertainty into reactor projects that involve participation from even close US allies. Coming out of the Calvert Cliffs decision, there was an effort to do a fresh assessment of FOCD. And that actually resulted in that SECI document referenced at the top. However, coming out of the fresh assessment, there was a vote by the NRC commissioners, and there were 3 different blocks of voting in terms of interpreting what the FOCD provision meant. You had 2 commissioners, Svinicki and Ostendorf, arguing that the NRC should reinterpret FOCD to allow for 100% indirect ownership. 1 commissioner voting to interpret that to remain at up to 99% is potentially allowable, and another commissioner, Commissioner Brand, arguing that no more than 50% in direct ownership was permissible. So still, 60 years later, we have these debates over what the FOCD provision means. And it continues to be this source of disagreement within the NRC, commissioners, the ASLB, NRC staff. Now, where this could be a problem in the future, at least the two examples that jump to my mind, Urenco is a British-Dutch-German company that's pursuing a microreactor, the U battery. Certainly, if there's an investment from those countries, it could potentially get hung up in FOCD issues. Terrestrial Energy is an integral molten salt reactor company from Canada. They have talked about potentially siting a reactor at Idaho National Lab. And similarly, some level of investment from Canada could get caught up in these FOCD regulations. In terms of a way forward, one of the cases discussed in the NRC document from the last slide involves a company, Syntachem, which in 1983 was to receive ownership of a research reactor, but due to upstream corporate parentage, several layers up, Syntachem was essentially owned by a Swiss entity. The NRC found this violated FOCD provisions. There was a back and forth between the NRC and Congress on this, and Congress ultimately passed a law to make an exception for this project. And the path forward was, as long as the NRC determined that there was nothing inimical about the project in terms of the common defense and security of the United States, the transfer could go forward, which it ultimately did. I don't know if how much that played into NRC's thinking years later, but the NRC actually did submit a proposal to Congress to try and fix this particular provision in the Atomic Energy Act. So 2001, the NRC chairman had called this FOCD provision increasingly problematic. So this was well in advance of the cases that we just discussed. The amendment that NRC proposed would direct the FOCD restrictions towards production facilities. So, for example, reprocessing facilities, and away from utilization facilities such as power reactors. Now, this would get rid of this problematic provision that is also, according to the NRC, essentially country neutral. So it treats investment from Canada the same as investment from China, or investment from Russia the same as investment from the UK, which is certainly not how we treat nuclear energy cooperation elsewhere in the US government. That amendment was reviewed at the time by the executive branch, including the National Security Council, Department of Defense, Department of State, Department of Justice, and none of those entities objected. And the NRC would still have the authority, the regulatory authority, to reject any problematic foreign investment under the inimical determination that it makes for all power reactor licenses. The inimical determination is incredibly broad, and I certainly came to the point of view during this research that amendment from the past was the right way forward today, and would allow the NRC to better manage the modern corporate structures, these international companies that are part of the global nuclear energy supply chain today, and better evaluate the applications rather than get caught up in interpreting this vague provision from 1954. So just to summarize briefly, I mean, the first finding is rather intuitive, I think, as is the general case for strengthened cooperation with US allies. Just the point that the development and demonstration of these advanced reactor concepts is substantially expensive, and being able to draw on a greater source of resources, greater pools of investment from close US allies, I think would help those efforts. And of course, as I mentioned, I did come to the viewpoint that Congress should amend the FOCD provisions. It's just been problematic in the past many times, and easily could be again in the future. And I also think that, especially with all the developments in the last 5 years, reconsidering our international nuclear energy programs at DOE is warranted and should be directed. I think there should be some direction towards supporting advanced reactor demonstrations and bringing in public and private investment from US allies. So I will stop there. And for those of you who have just joined, I'll repeat again. I'm Matt Bowen. I'm a research scholar with Columbia University's Center on Global Energy Policy. I'm here today with Chris Colbert, Chief Strategy Officer at NuScale Power, Joyce Connery, who is a board member with the Defense Nuclear Facilities Safety Board, Amy Roma, partner at Hogan Lovells. We're discussing nuclear energy cooperation between the United States and its allies. We will now move into a moderated discussion, and we'll open up to questions from the audience in a bit. For those of you joining us via Zoom, you can submit a question for the panelists at any time by clicking on the Q&A button at the bottom of your screen. For those of you watching the live stream on Facebook, you can submit a question there. You can also submit questions via Twitter using the hashtag CJEPLive and our Twitter handle @ColumbiaUEnergy. I'm going to turn now to our panelists for each of them to give their opening thoughts. So Amy, let me turn the floor over to you.
Thanks, Matt. So you teed me up very nicely because the subject matter that I'm going to address is the FOCD restriction. By way of background, my name is Amy Roma. I'm a partner in the energy practice group at Hogan Lovells, and I've been a nuclear regulatory lawyer now for about 17 years. Of those 17 years, I have dealt with the foreign ownership, control, or domination restriction of the Atomic Energy Act on a nearly daily basis. And so for people who think this is an esoteric provision that doesn't come up very often, it comes up quite a bit. I started my career at the Atomic Safety and Licensing Board and then moved into private practice where, among other things, I did the licensing, worked on the licensing for the Urenco USA facility in New Mexico, which was not subject to a foreign ownership, control, or domination restriction, but did go through a non-inimicality review due to the foreign participation of the owners of that company. I then went on and did the Constellation Energy Nuclear Group license transfer, where Électricité de France, the French company, came in and invested about 50% in that company. And that was my first really roll up your sleeves. How does FOCD work in practice? What are the business implications of it? And what does a negation action plan need to look like? We basically just did what everybody in the nuclear world did and borrow what our predecessors did. We just looked to precedent and just copied what they did for Amergen and kind of beefed it up a little bit in that case. Then I went on to represent, I did some work on Unistar, not much, and not on the FOCD provision, but I went on to represent Toshiba and the STP 3 and 4 licensing proceeding, where the NRC staff determined that Toshiba's 10% investment and equity ownership in the STP 3 and 4 project, with corresponding corporate governance provisions that limited their ability to exercise control over the company to align with their 10%, and a full-scale negation action plan in place that ensured that any decision-making authority over nuclear safety, security, and reliability had to remain in the hands of NRG, the 90% owner and a US company. And yet the NRC staff still determined that it was a violation of the FOCD provision of the Atomic Energy Act and was poised to dismiss the license. And it was only through a successful hearing that lasted several years and full-scale litigation at the Atomic Safety and Licensing Board that Toshiba was able to prevail. I've also worked on Central Vermont Public Service, a 1.73% owner in the minority owner in the Millstone nuclear power plant, where they had to put in place a full-scale negation action plan to mitigate any potential foreign influence when they were indirectly acquired by a Canadian utility for their 1.7% ownership interest, where they have no ability to exercise any control over nuclear safety, security, or reliability. Their only obligations were to provide money to align with their 1.7% interest. And then now working on advanced reactors and working on commercial non-power reactor projects, including medical isotope projects, where we're looking at doing deals with venture capitalists, private equity, foreign investors, foreign reactor suppliers that want to invest in projects. I have to remind my clients every single day that are looking at building demonstration facilities or commercializing their technology that they can take foreign money if they want to. They are okay as long as they're applying for a design certification, but if they want to actually apply for a reactor license, they are unable to do so without significant onerous restrictions in place, restricting the ability of the foreign government, the foreign country, the foreign investor, to provide input in how its investment moves forward. So I do FOCD every single day. I have never seen it apply the way that I believe it was intended to apply. I have seen the NRC consistently struggle with understanding corporate governance provisions and how control is exercised over companies, because it's primarily an agency that spends most of its time doing technical reviews. And so when Matt, you and I started talking several years ago, and you were looking for things where you're like, hey, are there any kind of things that you see as just an obvious thing to change? I resoundingly said OCD. Just eliminate the FD provision altogether. You could also, if people aren't comfortable with that, you could put some kind of provision in place that would restrict investment. I think you roll up your sleeves, and I think to the conclusion on your that made sense. You know, once you looked at the precedent, how it had been applied, and the restrictions that it had on investment, and kind of the absurd conclusions that we come to, where the NRC staff is arguing in a hearing opposing the issuance of a license to a 90% owned U.S. company with a 10% minority owner, that the reasons we should be concerned from a national security standpoint about that investment is that Toshiba might divert the nuclear technology. It's Toshiba's reactor design, or that Toshiba might divert special nuclear material. Well, Toshiba also owns a fuel fabrication facility in the United States and fuel fabrication facilities in Japan as well. So those arguments kind of lead you to absurd results. And so I wholeheartedly endorse removing the provision altogether, or just restricting it so that it doesn't apply to allies, and having the NRC apply a non-inimicality finding like it did for the Urenco USA facility, where because there was no FOCD provision, it was able to sit there and still evaluate the national security implications for issuing a uranium enrichment license, which, by the way, is the only uranium enrichment facility operating in the United States, to a company that has ultimate foreign ownership. I support this particularly in light of the fact that we now have CFIUS, the Committee on Foreign Investment in the United States. Most importantly, their job, it's an interagency review, and their job is to evaluate investment in critical infrastructure to determine what the national security implications are of that investment. And so given that we have CFIUS, that's their role, that the FOC, when there's FOCD investment, there's almost always a CFIUS review as well. We end up with these redundant reviews that lead to very onerous restrictions that impede investment on the NRC side, where CFIUS is kind of already doing that job. So I think that's it in a nutshell, and happy to answer questions when we get to that point.
Thank you, Amy, and thank you for introducing me to FOCD, what feels like a long time ago.
Long time.
So I'll turn to Chris for some comments.
Okay, thank you, Matt, for having me on this panel. Just a little bit, Matt mentioned my background. I've had, now it's hard to believe, 13 years in the nuclear business, but for 20 years before that, I worked in developing and deployment of large fossil plants. And as I like to say, having had a hand in creating sort of the greenhouse gas problem with those plants, looking for a way to help solve the problem with what we're doing with nuclear. So there's no zealot like a convert maybe, but anyways, here I am. So NuScale Power itself was formed in 2007 for the sole purpose of completing the design and commercializing our small modular reactor, the NuScale Power module. This revolutionary technology is capable of producing electricity and process heat for a variety of industrial applications including hydrogen production, refining operations, and thermal desalination for the production of clean water. If you look at the generation of greenhouse gas emissions, about 1/3 comes from the production of electricity. The other 2/3 comes from transportation and from process industries. If we can get into those markets, we can more rapidly decarbonize using the nuclear technology. NuScale is changing the nuclear game in that regard, and this year will prove it. We've been on an amazing journey for nearly 2 decades, and 2020 will mark an acceleration point in the story of small modular reactors here in the US. We will see the commercialization of America's first small modular reactor this decade. We are the first SMR to undergo rigorous design review by the US Nuclear Regulatory Commission, the NRC, and approval of our design will be completed in September 2020 with the issuance of the final safety evaluation report, or phase 6 of the NRC review. We just recently completed phase 5, and we're looking forward to this next milestone coming up so quickly and rapidly. Our upcoming design approval this fall is an extremely important milestone, not only for NuScale, but also for the new US NRC and the US government, as it will clearly establish the US leadership in the race to bring small modular reactors to market. The final outcome of our design approval process would further cement NuScale's position as a premier SMR design in this market, and is the only design ready to bring the benefits of our carbon-free technology to the homes of everyday Americans in a few years from now. The NuScale plant has unparalleled resilience and has achieved a paradigm shift in the level of safety for a nuclear plant. Safety comes first, second to none. NuScale has a triple crown of safety for a nuclear plant, a design that ensures that on a loss of all electricity to the power station, an undesirable situation for other nuclear plant designs in which caused the releases at Fukushima ultimately, each NuScale Power module in a NuScale plant that Matt showed earlier was safely shut down and self-cool indefinitely with no need for operator or computer action, AC or DC power, or additional water. This capability is a first for commercial nuclear power. Also, because of the size of our design and because the modules are contained within a pool of water in an aircraft impact resistant aircraft Category 1 seismic qualified building, if you were to have an event which we calculate to be once in a universe or once every 13 billion years, where we had a release outside of the containment, by the time you got to our site boundary, or about 35 acres, there would be no hazard to the environment or to people. Again, that allows you to show the safety of the design that, again, is unparalleled in the current operating fleet. As the clean energy transition happens here in the United States, and the many states have adopted or will adopt laws requiring 100% zero carbon electricity in the coming years, and utilities across the US are setting their own emissions goals for low carbon and carbon neutrality, further solidifying the key role that SMRs could have across our country to support diverse carbon-free energy portfolios and support a balanced mix of clean energy technologies. We are seeing that with our first customer, the Utah Associated Municipal Power Systems, and other studies that have been done in the Pacific Northwest indicating the need for a stable clean energy resource such as NuScale is providing. NuScale is the US leading near-term deployable and commercially viable SMR-based nuclear generation solution that is ready and up to the task of advancing clean energy and climate goals both in the US and across the world. We see that happening first here in the US, but importantly being able to do it predominantly out in the rest of the world, where we hope, and in contrary to Matt's chart earlier, to reestablish US leadership in the deployment of safe and safeguarded civilian nuclear technology. We believe that is a product that most other countries want, and the United States has an important role to lead in providing that to them as an option in the future. Thank you, Matt, and I look forward to questions that folks may have during that part.
Thank you, Chris. And last but not least, Joyce.
Thanks, Matt. First, I need to take care of some business because my general counsel's on the line. So I just want to let everybody know that I'm speaking on in my personal capacity and not on behalf of the Defense Nuclear Facility Safety Board, where I am currently a board member, nor on behalf of the US government. So my disclaimer is done, and just want to make sure you're watching, Kevin. So I want to thank Matt for his report and for the Center for Global Energy Policy for all the work that it does to look at the big questions that are surrounding the future of global energy, and specifically looking at the issues of national security, including both traditional big power competition in energy markets, as well as the trans-global security issue of climate change that, that we've seen talked about earlier. I'm honored to be here with Matt and Amy and Chris, each of whom I'm lucky to call colleagues and friends. I'd like to start my comments with Matt's paper, which I recommend that you each take the time to read, even though he did a lovely job of presenting it in PowerPoint form. It's interesting because if you see what he did in the paper, he took a very specific challenge with FOCD statute and its rather tortured history, and then he moved on to NuScale and how they are leveraging direct investment in their program. And then the broader question about what does this mean for programs within the Department of Energy that look at nuclear energy cooperation. So, and that's kind of why you see this panel evolve the way it has. So while I'm not an expert on FOCD, foreign ownership, control, and domination, I agree with Amy's statement that absurd outcomes are bad. And I would note that the restrictions in section 103D and 104D of the Atomic Energy Act are subject to wide interpretation. They're anachronistic and redundant with other sections of law. As pointed out, the NRC has the regulatory authority through licensing to make an inimicality determination. My only caveat here is that the NRC alone shouldn't, in my view, make inimicality determinations, that it has to consult with the broader interagencies, such as through the CFIUS process. It's been my experience that the NRC's fiercely guarded independence is not always kept abreast of the intricacies of the executive branch in terms of the puts and takes and risk evaluations of a broad spectrum of interests when determining such an inimicality position. We can talk more later if you're interested about the risk versus reward of some of the decision makings in the environment of international programs, but, and this is not to denigrate the capabilities of my colleagues at the NRC, you guys are the gold standard when it comes to technical issues, but I think in this case, you want to have the wisdom of what's happening with the State Department, with the Treasury Department, with the Defense Department, et cetera. So I also want to give a nod to Chris for his presentation on NuScale. There's been a good deal of time and investment by the United States government in the NuScale program, and I want to recognize the hard work and persistence of the company to move forward to make an SMR a reality. The challenge is going to be moving from the first of a kind to an nth of a kind milestone, and once you get there, that's going to lead to hopefully widespread deployment. The paper that Matt outlined talks about some of the investments and the partnerships that NuScale has with both the French, the Brits, and the Republic of Korea. And in one agreement, there's an equity investment in return for manufacture and supply of key components, and another collaboration with a fuel manufacturer to develop and supply fuel. So I don't want to press Chris on the details, which are likely not public or shouldn't be public. I want to comment just in general on the opportunities and challenges of such partnerships. So NuScale, in each of these instances, calculated for itself the risks and rewards of the partnership in relationship to that project. So the equity investment from the ROK is probably crucially important to move the entire project forward and provides a supplier of necessary components. The risks, which I'm sure NuScale has identified and mitigated, include the potential lack of redundancy in key components or the risks with quality assurance of parts that are coming from other places. So when you get to the point of Matt's paper, when you broaden out to examine the national security argument with regards to the imperative for the United States to move forward, not only to be involved in commercial nuclear, but a leading voice in the area, then it gets interesting because you see kind of the irony here. So the reasons for, and Matt alluded to them earlier, and I'm not going to get into them because there's been a spate of articles about how important U.S. influence in the sector is. But, you know, as Matt pointed out, we've lost capabilities with key supply chain components along the way. So the irony here is that U.S. companies need to partner with foreign entities in order to compete with foreign entities. That's kind of not lost, right? So you need to get these components in order to move your project forward and the equity investment. But at the same time, we want to make sure that the United States has capabilities in the supply chain as well. So all by way of saying that, you know, in the words of Facebook, it's complicated. It's not a simple answer. So I want to make sure you note that I'm not arguing that NuScale's approach detracts from national security. In fact, I think it's pragmatic and a logical way to move the project forward, so that it does become commercialized and we do regain some of the losses that the United States has suffered with both in the international and the domestic commercial spaces. And that's a net gain, not just for traditional national security, but also for the climate change issue outlined as well. But the point I'm driving at, again, is that it's complicated. Companies are going to make decisions based on survivability and the long-term health of their companies. They're going to be worried about shareholders. And hopefully they're also going to be worried about stakeholders, which includes where they're building these reactors, the communities in which they're building them, and the government, as well as the citizens of the world. So the question is, what is the government's role? And that's an interesting question, and that's the question that Matt poses in the last section, although he focuses specifically on the Department of Energy's international program within NE. I think that if you look at NuScale, the relationships and partnerships they developed were for the best interest of their company. And a lot of the partnerships that are created are going to be company to company based on specific needs. Now, there may have been instances where we had a trade mission or commercial officers overseas helped introduce NuScale to some of the folks that are working on similar issues in those other countries. But those were introductions. US government was not there playing matchmaker. So I just want to mention another interesting case because it shows kind of the pitfalls and promises of US government involvement in the sector. So when TerraPower was interested in moving forward on the traveling wave reactor, both the US government and TerraPower were interested in pursuing this relationship with a Chinese government entity. So in addition to the commercial relationship, the US government negotiated an agreement with China as an implementing arrangement under the US-China Nuclear Cooperation Agreement, otherwise known as the 123. The agreement was to cover joint work and permit the transfer of technology. And it outlined areas of cooperation, tech transfer mechanisms, and it recognized the need for exchanging scientists and engineers. We can have a whole other discussion about the visa implications of international cooperation. And it provided for materials exchange, all subject to laws and agreements. There was peaceful uses provision, and there was non-transfer to unauthorized purposes written in the agreement. This all fell apart, of course, in 2012, as Matt mentioned, because the administration and DOE determined that they were going to deny any new licenses to work with China, and they weren't going to renew the old ones. The reason cited was a case of the Chinese stealing nuclear information through a Taiwanese American citizen and a state-owned nuclear corporation. So while this foray into US government involvement in nuclear cooperation, likely due to the choice in dance partners, had an unfortunate ending, this type of arrangement might be attractive in the future. But it's also an object lesson in kind of the fickleness of international nuclear commerce. I mean, I remember back in the day, this is going to tell my age a little bit more than my gray line does, but back in the day when we were worried about Japan Inc. and we were worried about France Inc. and Chris is laughing because I think he remembers this, right? And now that's not so much of a concern as we're concerned with the entities like Russia and China. So I'm going to stop there. I have opinions, lots of them, and thoughts as well, but I want to turn it over to make sure we have time for questions, both from Matt and from our audience. And it's great to see so many friends tuning in today. Thanks.
Thank you, Joyce, and thank you for reading the whole report. I suspect that will put you in an elite group when all is said and done. Okay, so I think I'm going to give myself one question to each panelist before we open up to audience Q&A. So Amy, you've worked at the NRC, you've worked in export control space, Part 810, Part 110, nuclear liability matters, et cetera. So you talked about FOCD in your opening statement, but do you have any thoughts on where else in the US government maybe there are opportunities to look for collaborations or opportunities to strengthen cooperation with allied nations?
I have to take myself off mute, Matt. Thanks. That's a great question. I think there's a lot of things that I can think of. One of the things that I heard that was the most intriguing to me was I was talking to Honi, who's the director of NRR now, Office of Nuclear Reactors at the NRC. And he said that when he was at the NEA in Europe, one of the things that they were looking at was whether they could come up with basically an international kind of standardized reactor design approval, so that rather than having to go to the NRC and get your design certification and then having to get a similar type of approval in other countries, that they could develop a framework where there could be like an international stamp of approval on a reactor design. And then that could significantly streamline the actual licensing process when you build it in a country, and shorten the amount of time that it takes to kind of get the approval, getting the regulator up to speed on what the technology looks like, and implementing the new technology. That, I think, could be really interesting and could potentially save a lot of time, energy, and money. And so I know there's been some high-level discussions on that front, but seeing something like that, I think, could be great.
Okay, that sounds good. Chris, I have a question for you. I'm curious how you are thinking NuScale will be able to compete with Russia and China in terms of supplying reactors to other countries. I sort of assume this will be easier or harder depending upon the country we're talking about, but both Russia and China are able to bring financing to the table to support their reactor supply. I don't even know the last time Exim Bank supported a US reactor in another country. So I'm curious, how do you see things? What's important?
So first I'll note there was 3 questions, and I can usually only remember one at a time, but I'll try and hit all 3 of those, Matt. The last one, I don't know the last time US Exim financed a nuclear project. Maybe it was over in Taiwan. But they were considering providing some financing for Baraka, I thought, in that part of it, but they may not have in the end. But the good news is that Exim's been reauthorized. They have a 7-year runway to them. They have a quorum, and they're open for business for doing international financing. But going to your first question, how do we compete with the Russians and the Chinese? NuScale and I think most of the other advanced nuclear reactors in the United States certainly have a technology advantage, both in terms of safety and safeguard. And because we've gone to a system of really relying upon passive safety systems where we have, walk away safe really designs, don't rely upon AC or DC power or additional water or operator action, we really differentiate ourselves in the technology space. And the fact that that is proven or vetted before the NRC, which provides a great deal of comfort to most overseas partners that we're talking to. The challenge we have, and you hit on this, is really, where do we lose against the Russians and the Chinese? And where we lose is that they're really quite frankly willing and able to fund everything from the establishment of a regulator in a country to adoption of regulations, training their people, to paying for the construction and operation of the plant, and even taking back the fuel. Importantly, with Exim acquiring a quorum and a reauthorization, but most recently the International Development Finance Corp reconsidering and removing its restriction on investment in nuclear, we have one more tool in the toolbox for companies like NuScale to go overseas and provide a, what I would call an affordable product. We're not going to be the cheapest because the Russians and the Chinese can just buy their way in. They do as a matter of strategic interest in certain parts of the world where that's important to them. But, what I find is that most of those countries, and we have publicly announced work going on in the Czech Republic, Romania, Jordan, Canada, is that we just need to be affordable. And if we're affordable, then we went on the technology forefront for both the safety and simplicity of designs. So I'm pretty comfortable based upon what the U.S. government has done recently and what we're seeing from those overseas customers, which I just mentioned, the public ones. There's probably another dozen we're talking to on a confidential basis, that we're going to be able to compete effectively. We haven't been, over the last several years, but I think the U.S. government has really put their shoulder to the wheel. And it's not just the DFC, it's not just the XM. We find that Department of Commerce, Department of State, Department of Energy, who's provided over $350 million of cost share to NuScale on this journey. All those elements of the U.S. government are coming together in a way that I haven't seen, frankly, and I've only been in nuclear for 13 years, but and particularly the last 8 or 9, it seems to really be coming together in a way that I thought came together in a nice report from the Nuclear Fuel Working Group that kind of brought all those pieces together for us. So, you know, I'm actually looking forward to the competition. I think we're having more of the tools we need to be competitive, and I think we're continuing to see, you know, all branches of government, including the Congress, coming forward with legislation that goes from NEMA, NECA, NELA. There's all the sort of N acts and legislation, Advanced Nuclear Innovation Act draft being considered. All those things being put forward to enable the U.S. industry to really reclaim the space we had as a predominant and the leader in the civilian nuclear sector. And I think we can reclaim that, certainly. In that map where you see a lot of Chinese and Russian flags pursuing projects, you know, we hope to supplant those with U.S. flags. And I think we have the commitment, certainly from the executive branch and the Congress, to do that. So I'm feeling pretty good about it. Matt, I wouldn't have felt the same way a couple of years ago, but I think it's improving for, you know, quite dramatically.
Okay, thanks, Chris. Joyce, I have a question for you. You've done 2 tours of the National Security Council, one including as Director of Nuclear Energy Policy. I'm curious how you think about U.S. role in the international nuclear energy marketplace. In specific, what are the consequences or implications of a U.S. absence or perhaps a Russian-Chinese dominance of the energy market? I mean, what concerns do you have, if any?
Well, I think any of us have a lot of concerns, because the question is, for what purpose do you want to have this commercial engagement? Is it only commercial, or is it influence that is state influence? And again, we're in a different position than China and Russia. Our corporations aren't state run. I can't, you know, if I was a U.S. government official, I can't tell NuScale where to go and where to build reactors. But that's certainly the case with China and Russia if they choose to. And when you think about nuclear power, you're thinking about a 100-year relationship from, you know, beginning to end with that program, and our whole system isn't designed the same way. So I think Chris touched upon some of the challenges that we have, and we also know that in cases even of fossil fuels with gas pipelines, that's also been used as an instrument of state. And I come from a national security background, so that is a lever that a country can use to put pressure on another country if you have the access to those control valves. And I think the same thing for nuclear. So it is about the tools in the toolbox. And, you know, when you ask about Exim Bank, we did try to use Exim Bank to fund Baraka. It's hard when the UAE has, you know, a lot of funds of their own. Convincing them to borrow money from Exim Bank wasn't so easy to do. But they were, you know, great partners when it came to our bid in the Czech Republic. And that was a full-on whole of government approach. You know, at the end of the day, the Czechs didn't decide to go forward with that tender for, we had an AP 1000 bid, and it was between us and the Russians. But the effort itself was a whole of government approach. And I think that, again, you need to have all the tools, and you're not going to use all the tools all the time. The decision on IDF, I think, is great to finally remove the restrictions that we had seen at OPEC, and we tried to do that in the last administration as well. But now you have to attack the IFIs, the international financial institutions, and see if that they can also provide financing for these things. Our disadvantage is the fact that we don't have permanent presence of our corporations in some of these countries, because they go where the markets are, and they don't have the staff to have them sustained all over the world. Other countries use their missions to do that. And we can do the same thing to a lesser extent. It's a matter of mobilizing both the energy attaches, the commercial attaches, and educating them so that they know about our companies. But I think we also have to revitalize efforts to actually help countries build the infrastructure that they're going to need if they end up going with a nuclear power plant, which is helping them write their regulations, helping them build their regulatory infrastructure, help them with their emergency preparedness and response. The State Department's done a good job in the nuclear security realm, because that's where Congress was giving them the money. But now we have to actually put those monies in places that are more helpful. And I think at the end of the day, countries actually do want to work with the United States, in no small part because of our history with with this technology, in no small part to our excellent regulatory history. And I think, and the NRC licensing is seen as gold standards, but that only works if where you implement, they also have the ability to maintain the safety record that the United States has. So you actually have to help with that infrastructure. The companies don't have pockets deep enough to do those things at this point in time. And so that's why you have to look at consortiums. The other thing I would say, and I want to make sure that I mention it, is the landscape change that I've seen since I was pulling together the interagency is true. The interagency is working together. I think depending on which administration is in power, the power shifts, right, between the Department of Energy or the White House, or the State Department now is kind of ramping up again. But there's still a limited pool of people who do this work. We all know each other, and it's been the same people for the past 7 years, and we could probably, everybody in this room, name all the people that we know who work with these issues. But now what's exciting is you have the NGOs coming in, and they have some capabilities that are actually helpful and can bring to bear some analytics onto the program. You've got Third Way, you've got the Nuclear Innovation Alliance, you've got Fast Path to Zero, the Clean Air Task Force, the Breakthrough Institute, the Atlantic Council, the Energy Impact Center. Like, you know, there are a myriad of organizations that are focused on this like a laser beam, and they're putting their energies toward mapping out what the supply chains are around the world. And they're going to be able to feed information to the United States government in a way that helps us pick where the markets are that are of most interest, how far along they are, and where their gaps are, so that we can go about filling those gaps with the tools that we have as the United States government and the companies that are looking to go and engage with those other countries that are looking to move forward with their nuclear power programs.
Okay,
Sorry,
great. Thanks, Joyce. And now I think we'll move to questions from the audience. I see a number here. I'm going to try and find questions I can distribute to the three different panelists. I see one that seems like it's in Amy's lane. The question is, given that the language of the AEA, the Atomic Energy Act, is pretty clear on this matter, a legislative solution seems the most elegant. What are the odds of that? And are there any efforts underway to make that legislative change?
That is a great question. First, whoever asked that is correct. The language on the FOCD restriction in the Atomic Energy Act is pretty clear. And so the easiest way to fix it would be to strike the language altogether, or to otherwise amend it to add some qualifiers. Interestingly enough, tomorrow that the Senate Energy and Public Works Committee is going to have a hearing on the proposed American Nuclear Innovation Act, ANIA, which was just recently came out in draft form, which proposes to amend the FOCD provision to permit investment from countries that belong to NATO, the Republic of Korea, or I think it's Japan. And so I think we'll find out soon enough. I don't think it's going to sail through. I think there's going to be significant debate on that provision. I know people have very strong opinions about it, but I think we'll see if the ability to amend this provision, which didn't work back in 1999, may work again this time.
Okay. Joyce, I see a geopolitical question here I'm going to throw your way. Might the current rift in nuclear energy cooperation between Beijing and Washington shift under a potential Biden administration, or is there no possibility of bringing that relationship back to where it was 5 to 10 years ago?
Well, I think that you never go back to where you were 5 or 10 years ago. Whether or not there's a shift, I don't think it's going to be as dramatic as, putting everything back into place as to where it was, because not only have we evolved, but the behavior of the Chinese in a number of areas has also evolved and not necessarily in a good way. So I think one big consideration for our companies has to do with intellectual property. And again, it's up to the companies themselves. In some cases, they want to share their intellectual property in order to get the market share, and they're not too worried about sharing the light water reactor technology that they're allowed to share, so long as they get the follow-on contracts for fuel and for repairs, that's enough to keep them satisfied. So the companies sometimes make those decisions themselves, but it's when the intellectual property is taken and not necessarily offered that there's a huge problem. So I think we need to make a concerted effort, if we move to any kind of relationship with China, to understand what that looks like, to have better access to information about what the Chinese companies are doing and their relationship to the defense programs within the Chinese government. And again, it's always a tricky geopolitical situation as to whether to engage and try to change behavior, or when to withdraw entirely because the behavior has gotten to that point. So I don't see it shifting dramatically in the near term. I also think that China's struggle, frankly, is that they're going to have a hard time exporting, because they have a hard time keeping up with demand within China for what they need in order to sustain the energy needs of their society. So they have a lot of tentacles out there with their Belt and Road programs in other areas of infrastructure, nuclear a little bit less so. Russia's been more aggressive, bearish, than China, I think, in the making the nuclear deals than China has. But I think that's because they are kind of saturated a little bit within their own community and building their own nuclear power technologies.
Okay, thanks. Chris, here's one that is very specifically directed your way. Do those NuScale development costs that Dr. Bowen showed include the additional costs of getting the 60 megawatt design through, or just the cost of licensing the 50 megawatt design that won't actually be built? And I'm going to piggyback on that at the risk of challenging your memory. Can you talk a little bit more about the costs that you all have incurred, expect to incur on your way to a design that can actually be built? What are some of the costs that people don't think about that are out there?
So, Matt, I don't know if it's possible for you to put that slide on that showed the buildup of the 1.4 billion.
Let me try.
On the slide. But while you do that, I'll just comment. The first question is that we do include licensing of the 60 megawatt design in that 1.4 billion. To date, we've spent about $1 billion. We typically show this in a mountain climbing chart where we show, having ascended from the base camp at the bottom of the mountain that we're near on the top of it. But shown in that chart itself is really the breakdown of where you see those costs overall for getting to that 1.4 billion. And, one of the things I would just comment on, whenever you have a technology that has the opportunity to be as helpful as nuclear technology can be to humankind, there's also the chance for it to go wrong. And that's true if you have a new airplane design, a new drug. There's a lot of diligence put into it, and rightly so, to make sure that it's safe. But you're always talking something in the billions of dollars to license and get a new, really impactful technology out into the marketplace. So I would say that when you look at it, and people always talk about, gee, why is nuclear so expensive? I would say developing a new jet engine is expensive. Developing a new car, expensive. Developing a new drug, expensive. Because it has a huge impact, both positive, which is what you want to have happen, but if you do it wrong, there's great downside to it because of the interaction you have with people and the health and the environment. In terms of the costs, time is one of the great costs. If you look down there, general and administrative, just having a company sit there to be able to, like NuScale, all we're doing is developing a small modular reactor. And that amount of money being spent, it's every year you have to have the accountants, the lawyers, the folks in HR and whatnot to keep the organization going. So if you could do things faster, that cost comes down. True for many of these other things, where you have a start and stop, there's always this sort of a sense that, hey, if it takes you 1 hour to do something, if you start and stop 10 times, it still only takes an hour. Well, those of us who've done anything in our lives know that if you start and stop doing anything in your household, whether it's doing the laundry, washing dishes, or doing your taxes, that if you start and stop multiple times, it takes you a lot longer to get that done than it otherwise would have. So I think there's opportunities to reduce these costs over it. But, I still think it's going to be in that $1 billion range. I'd like to see it being done in less than the 20 years that we did. So, you know, if you could do it in 10 years, you know, 1.4 probably goes to $1 billion. But that's just a matter of having the capital available to do so going forward. So the first question was a very easy one, Matt. So the answer is that yes, and it's in that standard plant design, standard design approval for the nuclear power module of 54 million. That's where that 60 megawatt upgrade occurs. And the reason why that's so small is that, frankly, we're not changing anything to the module itself. It's that the module itself, upon further analysis, just produced a lot more steam, and we can prove it, and we can prove that we can operate it safely while doing so. So with that, I seem to see a cat in the back of Joyce's background there. Oh, there it is. When I left earlier, Joyce, it wasn't about the comment of how hard it is and other things. It's really when you talked about the graying hairline. I just figured you haven't gotten to the hairdresser with the COVID going on. So I know that's why my hair's gray. Thanks, Matt.
Okay. Let's see, I'll direct this one Amy's way. The question is there potential for the Department of Defense to drive adoption of SMRs as part of their sustainability strategy? How about microreactors for long-standing deployed locations, i.e. Bagram Air Force, AFG? Is there any interest from the DoD for projects like this?
Yeah, that's actually a very interesting question, and something that I think everybody here who's been involved in the nuclear space has noticed, that there's a whole flurry of activities going on right now from multiple different angles that is very interesting for us, and we're seeing a lot of support in areas we haven't seen it before. So the Department of Defense is evaluating two different projects. They're evaluating a project where they would deploy a SMR for use on a remote base so that it could have energy security and independence from the grid. That's one project, but another project that's moving forward is a microreactor project where 3 companies were selected and are under contract with the Department of Defense to provide preliminary design work for providing a microreactor for use at forward operating bases. And so the specifications that the technology would need to meet were kind of pretty prescriptive. It needs to be able to be loaded in the back of an airplane, flown over, and be able to be dropped in the ground and operational within a matter of few days. And they were also required to use I think there was a preference for a specific type of fuel. And so Westinghouse, X Energy, and BWXT were the 3 companies that were selected for that. So the Department of Defense is playing a role that I haven't seen them before. I know that over the years, there's been reports here and there where the Air Force was considering using advanced reactors or small modular reactors to provide power for bases. But we're seeing a movement now with the forward operating bases and the evaluation for the military bases for just power generation that are interesting. And I'd be interested too to see if these are actually followed through. If there's an administration change, or right now they were able to provide funding for the preliminary design work for the microreactors for the forward operating bases, but the project's not funded for the next design phase, and so there's a lot up in the air on whether this would move forward. But they're both interesting areas where DoD is providing support, and the support that they're providing for the defense side would be able to cross-apply into the commercial side, because it would help advance the design work and potentially get reactors up and operating so that you have operational experience to inform commercial projects.
Okay. Okay, I'm going to go back to you, Chris, because that's just what the next question. Chris, are there specific countries for which NuScale needs support from the US government in the form of EXIM or other financing, and or 123 agreements or other policy changes?
Yeah, so the world's a big place. And there's always a lot of talk about getting more 123 agreements and more markets open. But frankly, with the markets that we have open, we have plenty of opportunity, and we're not we're going to be wildly successful just in the markets that we can access. Not to say more isn't better, and that we would like to get our technology everywhere and every place, but we have a big challenge just doing what we have in front of us. And I think the U.S. government has taken those steps to provide the impetus for doing that, particularly with work being done by DFC coming to the fore, but also work being done at Department of State, Department of Commerce. We have a number of advocacy requests that have been approved. We're working with the government there, as well as working with the Department of State on their first initiative to move things forward, and with the Department of Energy, where they're always in conversations with people that have made just the introductions of, here's one of the U.S. suppliers for this type of technology, of getting in there. And, it's interesting, right? Because as a private industry kind of person in the United States, the joke is, if government is showing up to help you, you're in trouble. Everywhere else in the world, the government is intimately involved, more so than they are in the United States, in nuclear. They typically own the nuclear plants, or they have indirect ownership through the ownership of the state-owned companies. So it's so hand in fist that when we go overseas as a company, if you don't have the U.S. government with you in the room in some way, shape, or form, they see that as being, okay, they're not the ones that we should be talking to because the U.S. government isn't there. On the other hand, you have the U.S. government, which is like, hey, we believe in the free enterprise system. We want to pick winners and losers. So we have to be careful if we show up in a room with NuScale or somebody else, because then it feels like, we're picking a winner or a loser. So, I think we're getting better at that, quite frankly. And, we're finding ways to work around that. And I think there's just a growing recognition, at least in the U.S., that, my competition isn't the U.S. reactor companies. It's China and Russia, depending upon where you are. And I think the U.S. government has realized that. And importantly, those countries that want to have options, they've asked the U.S. government, they've asked us, how can we get, this technology, whether it's NuScale's or Holtec's or anybody else's, Westinghouse, how do you, find a way to get me a plant that's affordable. I understand you're not going to do the same things as the Russians and the Chinese will do, but can you get something that I can afford and I'm comfortable with having that gold stamp of approval from NRC and just the whole part of a U.S. safety culture that goes along with it. And let's keep in mind, not only do we have the safest operating fleet, we also have the most efficient and effective operating fleet when you look at just the cost per megawatt hour. So we're doing something right. And I would argue, and this is what was first taught to me when I came to nuclear 12 years ago, is that what people found in the nuclear fleet, as they improve safety, they improve their operating performance. And in the NuScale design, we find that same thing, is that by making it simpler and making it safer, we've made it cheaper to operate and maintain. And so, those things go hand in hand, and it's a, it's not the circular economy, but it's a virtuous circle for sure between those two things helping each other out. So I think that, the markets that the U.S. is focused on to move forward, DFC is important. Last budget, they passed the European Energy Security Diversification Act, which again looks to provide resources for all U.S. energy sources to provide U.S. solutions to our friends and allies in other parts of the world, particularly Europe and Eurasia. And just turning back to one of the points that Joyce, or questions that Joyce asked, and Matt was in your paper about allies. As we work with the Koreans or we work with other designers, it's not just because we're doing it. In some instances, we don't have other options, right? The U.S., we figure that right now we can build maybe 75% of our NuScale Power module or plant with existing U.S. capability. It would require another $500 million of investment to get that capability in place and to fill those gaps. So in some ways, we're relying upon those allies, whether it's Korea or Japan or France or whoever, to help fill those gaps. Some of those companies are, quite frankly, they're in the United States. So, you talk about fuel, the fuel's actually being built up in Richland, Washington. So, that's not really the concern we have there. But importantly, if we're going to compete and win, we need to be able to scale rapidly to get our products out there in as many markets as quickly as possible to make sure we establish that sort of critical mass. And the good thing about the NuScale design is that there's numerous locations in the globe, many of them in allied countries, where we can build the critical parts of our reactor design. And if we're able to use that supply base and use their XMs and their DFCs to help get as broad a footprint as possible into as many markets as possible in countries that want, U.S. technology and safety, it's all to the better, both from NuScale individually, but from a corporate standpoint for all of U.S. nuclear, and from the U.S. government for wanting to see the technology used responsibly and safely. So I see there the need for the allies, the alliances. I think that's how we further leverage what we do well in the United States. We can act in teams, and we can team up with people, and we can compete, and we know how to do that. And so just having that ability to do that, I think, is really going to be something that's going to be enlightening, I think, over the next several years as we see this play out. The last thing I'll point out is that, this is one of these things where we're going to have some fair sharing of both the benefits and the rewards. And that's kind of been the gripe of, U.S. as we pay 24% of the freight at some international institution and we get 5% of the benefit. That needs to be worked out. And we're very upfront in dealing with that question when we talk with, people who want to either invest or supply from foreign countries. And when we talk with the Department of Energy, who has invested, a large amount into NuScale, it's still 2/3 floor, but still $350 million is a large amount. And they're not looking for a purely, financial dividend return. They're looking for return in terms of U.S. security interests and also for U.S. jobs. So we need to make sure that we balance all those parts of the equation for it. And I think we're getting, better at that. It used to be that, sometimes you went into some areas and it was all, about security or non-proliferation, and commerce was kind of like a dirty word. Commerce, we can't be talking, commercial stuff. We're only talking about this other stuff because that, we really need to incorporate all those things because it serves the national interest together. Again, another virtuous circle where if you can do both, they feed off of each other and they're not exclusive. So sorry for kind of a long-winded answer, and I'll turn it back over to my fellow panelists and to Matt.
Yeah, no, not at all. Thanks, Chris. And mindful that we're sort of coming up on the end of our session, there are two questions that I think I'll throw open to Amy and Joyce to answer as they'd like. I can't resist asking this question: what about the possibility of SMRs on the moon or to power icebreakers, as the Russians do? And also, do you see any opportunity to discuss best practices with other nations, particularly US regulatory frameworks, through any multilateral mechanism, for example, through the cooperation programs with the IAEA?
I'm going to jump in to take the second question so that Amy has to talk about the moon. Just kidding. So yes, there's plenty of opportunities to exchange best practices. The NRC does this quite well with their international programs. They're a very small international programs office, but they are integrated into the rest of the NRC programming. So they actually do training there to help regulators from across the globe and provide best practices. I think that even though it has its limitations, Matt, I think the Gen X forum or the Gen 4 forum is actually quite helpful to understand where other countries are going, because it's important, even if we're not going to explore that technology, to understand what technologies other countries are exploring and what the challenges they're going to face. I think collaborating on international standards, while it seems, again, esoteric and mundane, is actually hugely important for the interoperability if we are at a point where we can actually deploy across the globe so that we're all talking in the same language and we all have the same standards for both build and even decommissioning as well as operations of reactors. So standards, I think, whether it's IEEE standards or ANS standards, I think are hugely important. I think it's something we should invest time, energy in. The international conventions, I think, the government of the United States should pay a little bit more attention to who and what level we send representatives to these international fora. I think we don't do well enough putting higher level officials in these capacities to go and represent U.S. interests in these arenas where they're actually making decisions that will impact how we deploy nuclear going forward. So I think there's a lot of opportunities for best practices exchange. I think it's something that we do both on a bilateral and a multilateral way. I think on the bilateral area, and we didn't really get to talk about this, but when you talk, Matt, about what DOE and EE can do internationally, there's the bilateral programs, which are as important as the multilateral programs. And what we are looking at is, what we've looked at in the past is how do we have this conversation with another country? So we started these high-level bilateral discussion groups like with Japan and Korea, where we brought folks from the interagency to talk about a wide range of issues that impact nuclear. So it's not just about commercialization, it's about safety, it's about security, it's about non-proliferation. We bring the NRC to the table. We talk about decommissioning, because again, there are synergies across the globe when it comes to the reactor fleet that will have to be decommissioned, or the remnants from, like we have from our weapons program that have decommissioning challenges. So I think we should consider that as another opportunity to share best practices. So the moon to Amy.
All right, so I got the moon. So yes, you can use advanced reactor designs on the moon. You can use them on Mars. Anything that has to do with powering space propulsion or powering, a colony on Mars, you'd probably be looking at a combination of solar and nuclear. So yes, icebreaker technology, yes. Russia and China are both building new state-of-the-art icebreakers to further explore the Arctic. And the president recently directed a study to look at modernizing the US icebreaker technology as well. So that as well. So yes to both of those. There was a fusion question. I'm just going to throw that in here. Somebody had asked how these provisions that we're talking about apply to fusion. For the most part, consider everything that we talked about applies in some capacity to fusion as well. The NRC has not quite figured out how it's going to regulate fusion. And so whether the FOCD provision as it stands applies, no, not on its face, but it could. If Part 50, which is the NRC regulations that regulate fusion, as a fission, are amended to include fusion in some capacity, it remains to be seen whether that would happen. But all these bills and legislation that we're talking about define our advanced reactor to include fusion as well. So yes, that gets folded into the discussion. And on the international cooperation, one thing to just add to what Joyce said is fully agree on all the things that she just said. The American Nuclear Innovation there's too many pieces of legislation. ANIA, the proposed nuclear infrastructure bill, has a provision there that would propose to beef up the NRC's Office of International Programs to help support further collaboration between the NRC and other governments on a whole host of things. And so that's a really important element, considering we live in a world where if we're building a nuclear power plant on the commercial scale, we want to build it in the US as well as abroad as well.
Okay, great. My apologies to the audience members whose questions we didn't get to. There was one, what about storage of nuclear waste? Isn't that the real problem? And I will say stay tuned, because that's my next report. And I'm ending on a self-serving advertisement for my next piece of work. So thank you to our speakers for joining us today. Thank you to our audience for tuning in. As we mentioned, the full video recording of this event will be available on our website in a few days. Thank you and enjoy the rest of your day.